Today I would like to take a moment to explain a crucial concept in maintenance of electrical generators. Stator partial discharge, or as many would call it, PD. To make this concept easy to digest, let's start with an analogy involving a natural phenomenon we are all familiar with, a thunderstorm. Imagine a thunderstorm. High up in the sky we have clouds charged with the high voltage potential. The ground below us represents potential zero. The air between the clouds and the ground acts as the insulation. When the voltage difference between the clouds and the ground becomes too great, it overcomes the insulation properties of the air. The result is the full discharge of electrical energy in the form of a lightning strike. Now, let's bring this analogy into the context of a generator stator. In a generator, the high voltage potential, it's nothing more than the copper, and the ground potential, it's nothing more than the stator core. The insulation system in the stator winding acts like the air in our thunderstorm scenario. However, unlike a full discharge that spans from the clouds to the ground, the partial discharge is a localized electrical discharge that occurs within the insulation material itself. Some may ask, so why is it called partial? It is called partial because it doesn't bridge the entire distance between the high potential, which is your copper, and the zero potential, which is the core. It happens at the localized point within the insulation where the electric field is strong enough to cause a breakdown, but not enough to create a full path to the ground. Think of it as a tiny localized lightning or sparks happening somewhere between the cloud and the ground within the air. While partial discharges might seem minor compared to full discharge, they can be quite damaging over time. Repeated PD events can erode the insulation material, leading to eventual insulation failure and potentially severe damage to the generator. That's why detecting and managing partial discharge is crucial for the longevity and reliability of electrical generators. And by using advanced monitoring and diagnostic techniques, you can identify and address partial discharge issues before they lead to significant failures.